This lecture is the 34th in the list, and what we are going to do is to solve minor 2 problems, in which indeed there are major problems, and if time permits, more about the 2 brothers, capital PDF and small PDF, probability distribution function, probability density function and probability distribution function. Minor 1, the first problem was minor 2. Problem 1, let me state the problem. 2 LTI systems are characterized by the following impulse responses. H1t is half 1 plus 5 e to the minus 2t ut minus delta t, and the other is H2t is equal to 1 half 1 minus 4t e to the minus t ut, and what you have to do is, this is system 1, this is system 2, you have to determine by Fourier transform techniques. This is specified by FT techniques the outputs of each of these 2 systems, that is y1t and y2t. You have to find out with x of t given by cosine of t. The point for this example was to show that although the impulse responses are different, they are quite different, the outputs to x of t equal to cosine t is the same for both, and this happens to be, both of them happen to be sin t. Why does this happen? It is an LTI system and same input, the systems are different. Why does the output remain the same? In other words, there is not a one-to-one correspondence between the input, not input, one-to-one correspondence, yes.
The system is smaller than the output.
Say it again.
The system is smaller than the output.
That's right. Why is it that 2 systems have the same output when you give the same input? Why is it that the system is not unique?
The Fourier transform consists of some delta function.
Fourier transform consists of delta function. That is not the answer. Cosine t is not a function, which this is the correct answer. Although I don't think Pankaj got full marks on question 1, but even then his answer is correct. Cosine t is a linear combination of 2 eigenfunctions. If it was an eigenfunction, then the output of the system would have been unique. If you had e to the st only, let us say e to the jt, half e to the jt, then the outputs of the 2 systems would be quite different. But what you are doing is you are applying 2 eigenfunctions, a linear combination, and therefore the output is not necessarily a constant multiplied by e to the jt. It is not. If you apply e to the jt, then yes, it is true, it would be h of jt, no, h of j multiplied by e to the jt, where capital H is the frequency response. Here it is different. And what is important is, you have been specified that you cannot apply convolution or any other technique. You have to apply Fourier transform. And the solution proceeds like this. The solution, one has to be one on his toes. It's not a routine problem, because delta functions are involved and complex calculations are involved. Alright. The solution is like this. H1 of t is half 1 plus 5 e to the minus 2t ut minus delta t. So the first thing you find out is H1 of omega, the Fourier transform of this, half ut takes care of 1 by 2 j omega, this 2 comes from half, and ut transform is 1 by j omega plus pi delta omega, but then you have to divide by 2 because of the factor 2 here. This takes care of the factor, this takes care of the constant 1. Then for the other one, 5 by 2 e to the minus 2t ut, therefore it shall be 1 by j omega plus 2, j omega plus 2, and then for the delta t it should be minus 1, alright. And therefore also you notice that the input x of t is cosine t, therefore capital X of omega, the Fourier transform of cosine t, is simply, yes, half times 2 pi, which means pi delta omega minus 1 plus delta omega plus 1. And therefore, the only two frequencies which are involved are omega equal to 1 and omega equal to minus 1. And therefore, all I need is h1 of 1 and h1 of minus 1. Now, if you substitute this here, h1 of 1, what happens to the delta function? 0, because it exists at omega equal to 0 only. And therefore, what I have is 1 by 2j plus 5 by 2, 1 by j plus 2, alright, because omega is 1 minus 1, and here we shall have minus 1 over 2j, because omega is minus 1, plus 5 by 2, 1 over minus j plus 2 minus 1. And all that I have to do now, all that I have to do now is capital Y of omega, capital Y of omega shall be h1 of 1, alright, pi times h1 of 1 delta omega minus 1, alright, plus pi times h1 of minus 1 delta omega plus 1. And therefore, what I have to do here is to substitute for h1 of 1, substitute for h1 of minus 1, and then simplify. Now, in these simplifications, there is a small trick that one applies. That is the trick about, you see, h1 of 1, for example, is 1 over 2j plus 5 by 2. Now, this complex quantity, 1 by j plus 2, well, we write as 2 minus j upon 5. This should have been obvious, so 5 and 5 cancels, and minus 1, and therefore this is 1 over 2j plus 1 minus j by 2. I can write this as plus 1 over 2j. Is that okay? Minus j by 2 I can write as 1 over 2j minus 1, and you see that 1 and 1 cancels, and therefore I simply get 1 over j. Alright? If this trick is exercised, then the problem becomes extremely simple. What would be h1 of minus 1 then? It must be the complex conjugate, so it should be minus 1 over j. And therefore, my total problem becomes y of omega equal to pi by j delta of omega minus 1 plus pi by, well, this would be minus, this will be minus pi by j delta omega plus 1, and you can see that this can be written as 1 by 2j 2 pi delta omega minus 1 minus 2 pi delta omega plus 1. And if you take the Fourier inverse of these two, obviously y of t, have I done it correctly? Obviously the function is sine of t, alright. The simplification, many of you were bogged down in the simplification. In a similar manner, the other function that is h2 of t is equal to half 1 minus 4t e to the minus t ut, and therefore h2 of omega should be 1 over 2j for the factor 1 plus, yes, pi delta omega divided by 2. Is that correct? 1 over 2 j omega, that is correct. Is this okay? Pi by 2 delta omega? Alright. Then minus 4 by 2 is 2 and t e to the minus t, that means j omega plus 1 whole squared. Alright. Now you can also simplify this, that is h2 of 1, this is something we require, and h2 of minus 1. Do we have to calculate both? No. If we calculate h2 of 1, the other one is complex conjugate. So there is a time saving here too, time saving device. And h2 of 1 is 1 over 2j, delta omega does not count, minus 2 divided by 1 plus j whole squared. This also can be simplified, make the denominator a real quantity. Well, it may not be needed. Either way, it doesn't afford much of a simplification, but nevertheless it is prudent to do this. This would be 1 over minus 2j minus 2 divided by 1 minus j whole square. You can multiply by 1.
So 1 plus j whole square is 2j.
1 plus j whole square is 2j. How wonderful. Why did you wait so long? This is 2 divided by 2j. Alright. What about 1 minus j whole square, my dear?
Minus.
That's right. So, my h2 of plus 1, let me make this simplification, and you see that no more calculation shall be needed. This will be minus 1 over j. Is that okay? Alright. And so h2 of minus 1, well, how much is this? Minus 1 over 2j. And h2 of minus 1 plus 1 over 2j. And now we multiply and simplify, we shall get the same, exactly the same result. Many of you did pages of calculation to be able to arrive at this result.
So would they be same?
No, there is a slight difference.
Minus half.
Okay, y2 of t, the outputs are not the same. y2 of t minus half sin t. Well, I could have made them identical by giving the input h2 of t by multiplying by minus 2. I could have done that. That means h2 of t, instead of the factor half, there will be minus sign. I could have done that. But even then, you see the impulse responses are absolutely different. The outputs are identical. Question number 2. No, there is another part of question 1. No, question number 2. Question number 2, the first part was an elementary question, and the marks allotted to question 1 was 6. Marks allotted to question 2a was only 2, and it should have occurred to you that the answer should have been very simple. Many of you faltered. Well, let me write it. What you have to do is to find out what is given is x of n is a discrete signal with a DTFT, discrete time Fourier transform as capital X of capital omega, and P of t is a continuous signal with a Fourier transform of capital P of small omega. And what you have to find out is the Fourier transform of y of t, where y of t is equal to summation n equals minus infinity to infinity x of n p of t minus n. Now what we do is we say that capital Y of omega, we apply the usual formula, that is minus infinity to infinity y of t, that is summation x of n, this is over n, p of t minus n e to the minus j omega t dt. Agree? And then what we do is we interchange the summation and the integration. We bring the summation on the left because n and t are independent of each other, and if we do that, then x of n is a constant as far as the integration is concerned, and therefore what we get is capital Y of omega is equal to summation over n, x of n remains like this, minus infinity to infinity p of t minus n e to the minus j omega t dt, and you recognize this as the Fourier transform of p of t minus n, a delayed function, and therefore this is capital P of omega e to the minus j n omega, and therefore my capital Y of omega becomes summation x of n, n from minus infinity to plus infinity e to the minus j n omega, and as far as P of omega is concerned, it is a constant as far as the summation is concerned, and this you recognize as the dtft, but not with an argument of capital omega. The argument is small omega, and therefore this is capital X of omega times P of omega. Many of you wrote this as capital omega, which is obviously wrong. Alright. This was the answer to question 2a. Question 2b. Question 2b says that the center of gravity of a signal x of n, a discrete time signal, is defined as summation n x of n infinity n equals minus infinity and summation minus infinity to plus infinity x of n. If the dtft of the signal x of n, capital X of omega, is given as e to the minus j omega 1 plus 1/6 e to the minus j omega minus 1/6 e to the minus j 2 omega, then you have to determine the CG of this signal without finding x of n, even though this was specifically mentioned without finding x of n. Many of you did find x of n, which means that you have not read the last line. Okay, I should not have given any credit, but I have given some. Don't argue, I did it correctly, my result is correct, because I didn't want that way. Alright, now here without finding x of n, one, it should have occurred to you that summation x of n e to the minus j n omega, by definition this is capital X of omega, and therefore if omega is 0, then this term goes to 1, and therefore the denominator is simply capital X of 0, and in the numerator j dx d omega, this we have already done, is the Fourier transform of n x n. Is there a minus sign? No. Let me check. No, there is no minus sign. Alright, and therefore what we do is summation, obviously this is equal to summation minus infinity to plus infinity e to the minus j n omega, and once again we apply the same trick, that is we put omega equal to 0. Therefore the summation of n x n is simply j dx d omega at omega equal to 0. Therefore the CG becomes equal to j dx d omega divided by x, the whole quantity evaluated at omega equal to 0. Well, it is more expedient to evaluate both rather than the ratio. The ratio, once again you have to simplify and all that. Now in this calculation many of you made silly mistakes about arithmetic. You see, capital X is given as p omega over q omega, and you know what is x prime, it is q squared omega q omega p prime omega minus p omega q prime omega, and instead of simplifying and wasting time, you put omega equal to 0 directly, then many things simplify, and this comes as minus j, well, capital X of 0 after numerical simplification comes as 1, and capital X prime 0 comes as minus j 7 by 6. This is the correct result. Now, if you, those who have made mistakes in this simple arithmetic manipulation, I have deducted at least 1.5. Whatever be the way you did this, the total marks were 6. At least 1.5. If I have deducted more, then it means you have made more mistakes. Now, one of the things that I cannot forgive is the following. I consider it as failure on my part. I will tell you why. Summation n xn, n equals minus infinity to plus infinity, summation xn, n equal to minus infinity to infinity. What is the kind of answer which would make me frustrated as a teacher? And it did in a large number of people. What? No. Nobody did that, thank God. But there is something else. You found, many of you found this to be an imaginary number. Many of you found this to be negative. Is that okay? Is that possible? Negative number, negative real number?
Yes, sir.
Yes, that is possible. Okay. That is possible. But if you find CG as a complex quantity or an imaginary quantity, obviously you are having a fantasy. It's not a real world. All the signals are real. And unless you go perpendicular to the real world, that's the J axis, you cannot get an imaginary answer. All right, question number 3. I thought question 3 was extremely simple. Question 3 says f of x is a right-sided sequence, right-sided function starting at x equal to 0. That is, f of x is non-zero for x greater than equal to 0. It is 0 for x less than 0. This is the definition of f of x. That is, it's a right-sided function. Can I have your attention? And it is also given that twice f of x, a differential equation is given. And intentionally, instead of t, I put x. It doesn't matter what the independent variable is, you can always transform to the S domain. Twice f of x plus beta. Now note this carefully, 0 to x, sine of beta x minus zeta, f of zeta d zeta is equal to cosine of beta x ux. What I had expected you to do is to solve for f of x from this equation, and many of you differentiated. That's the worst mistake that you can do. Differentiation will not give you a result. Why not? Why not comes in the following. You see, 0 to x. Let's consider this function, indefinite integral first. Sine of beta x minus zeta f of zeta d zeta, indefinite integral. Obviously, this will be some function, let's call it g, some function of zeta and x, isn't that right? Plus a constant. Now, if I make a definite integral 0 to x, obviously this will be g x minus g x 0. All right. This is the reason why your differentiation failed, because in your differentiation you put only the first term gxs, and you said sine beta x minus x, that is 0, and therefore the second term drops out. How could that be? You ignored that the third term, that is the lower limit, is also a function of x. X is not, I repeat, it's not the variable of integration, and therefore it failed. The correct thing would have been to take Laplace transform of both sides. And let me write the equation again, 2f of x plus beta integral 0 to x sine of beta x minus zeta f of zeta d zeta equal to cosine of beta x u of x. Now I take Laplace transform, obviously one-sided or two-sided? Well, two-sided or one-sided, it doesn't matter because, okay. So 2f of x plus beta, now this is the convolution of sine of beta x ux, this is important. Why this ux? Because of the limits 0 to x, alright, ux, then f of x. So beta, I'm sorry, Laplace or Fourier?
Laplace.
Oh, I said Laplace, okay. And the right hand side cosine beta x ux is given as s divided by s squared plus beta squared. This is, I made a mistake, this is f of s, alright, and therefore what we get is 2f of s plus beta. Laplace of a convolution is the product of the two Laplace transforms, so beta f of s and beta divided by s squared plus beta squared equals to s divided by s squared plus beta squared. A point to notice, there were precisely 6 scripts, I think, in the total class where the Laplace of sine beta x ux was written as beta squared divided by s squared plus beta squared. Now, how can I forgive you in a open book, open notes examination if you cannot write down the Laplace transform of sine beta x ux? Alright, so that gave them a beta cube term and things like that. But anyway, what we have now is f of s. There is another point which I want to mention here, 2 plus beta squared divided by s squared plus beta squared equal to s divided by s squared plus beta squared, and you can simplify this to f of s equal to s squared divided by 2s squared plus 3 beta squared. I think the simplification is obvious, alright. In order to invert this, I write this as half s squared plus 3 by 2, which I can write as square root 3 divided by 2 beta whole squared and s. Now, those who made the mistake know where they made the mistake. After reaching this point, square root 3, no, 2 they wrote square root 2, but 3 was left intact. It should be square root of 3 by 2. If in such manipulations you carry out a mistake, then you lose a var for the lack of, you remember that nursery rhyme? No? Pardon me? You better recall. A var was lost because of a small horse nail. Alright. F of s half s divided by s squared plus root 3 by 2 beta whole square, and therefore f of x, once again something else which people made a mistake. This is obviously a cosine of root 3 by 2 beta x. That is something which some of you failed to mention, and I couldn't but deduct at least half a mark for this, because otherwise the solution is incorrect. Question 4, many of you in question 4 did a lot of algebra, whereas algebra was not wanted at all. All that you had to do was to draw pictures, which makes things obvious. Question 4 says, given the band pass signal spectrum sketched like this, B, 2B, 3B, this is an extremely interesting question. Frequency in hertz, minus B, minus 2B, minus 3B, and the amplitude is A. The spectrum is like this, B, 2B, 3B. The spectrum is like this, 2B to 3B linear, and then comes down abruptly. This is the spectrum. The amplitude is A. Given the band pass signal spectrum shown in figure 1, sketch spectra of the impulse sample signal for the following sampling rates Fs and indicate which ones are suitable for subsequent recovery of the original signal. There are 3, Fs equal to 2B, Fs equal to 2.5B. What is the unit of B? Hertz. And C is Fs equal to 3B. Let's look at them. Let's look at the resulting spectra carefully. I can draw on the same, but I think things will get complicated. So let's draw for Fs equal to 2B, the spectrum. The original ones shall remain, that is B, 2B, 3B. And I have to draw both the sides, otherwise things will not be clear. Minus 3B, it goes like this and comes back like this. Okay, now due to the impulse, due to sampling, there is an overlap of the spectra. It's a periodic repetition, and the sampling frequency is 2B, and therefore this spectrum shall be repeated starting from 2B minus 2B and 2B plus 2B. 2B minus 2B is 0, and therefore it starts here and goes like this. All right, and then this one also repeats like this. Okay, what about this part? Pardon me? Minus 3B will now start at plus B, and therefore it will go like this, and similarly it will fill up like this, and so on. That's what will repeat. Is that clear? All that you have to do is to recognize the edges and subtract and add 2B, because that is the sampling frequency. All right. Now, obviously from this one can recover the original signal, right? By using a band pass filter which passes, tell me what will be the band pass filter which passes these greens. Okay, I can use a band pass filter to recover this, and therefore I can recover the original signal. All right. Now let's see Fs equal to 2.5B. That is very interesting. Yes.
So usually what we give is strict inequality for cutoff frequencies of a band pass signal and all signals. In this case, that strict inequality will not work.
No, it will not work. There is no guard band here, and therefore some aliasing is inevitable. Ideally, the spectrum terminates at 0, and so we make a sharp band pass filter. This is all theoretical, I mean ideal.
So if you say practically it's not possible, then with the
Practically it is possible you have to tolerate some amount of aliasing, a small amount of aliasing. That's always the case.
So even ideally, can we have the equality?
Ideally, yes.
Even ideally.
Ideally, yes. You see, it cuts off at 2B, so I only retain this green.
So
I don't.
minus 3B or 3B.
The single point won't affect.
That point would not affect, because anyway there is a discontinuity here from minus 3B to from 0 to plus A, and therefore it will not matter. Let's look at Fs equal to 2B, Fs equal to 2.5B. Now you shall have an interesting episode. You have B, 2B, 3B, minus B, minus 2B, minus 3B, so what we have is, original one was this. Oh, I beg your pardon, not this. Original was this. Now let's see what happens. This 2b, you have to subtract 2.5b. So it starts from 0.5b and goes up to plus 0.5b. Alright. Now this 2b minus 2b now starts at plus 0.5b and ends at minus 0.5b. So it goes like this. And if you add the two, obviously it would be a flat spectrum like this. So the addition would be like this. A rectangular pulse like structure. In a similar manner, from 2b to 3b, what will happen? Another pulse will be added like this. And this will continue. You see, it's a spectrum shaper rather than anything else. From triangular spectra, you get rectangular spectra. And there is no way, no filter on earth can recover the original signal. Alright? Even though the sampling frequency is higher. Originally the sampling frequency is 2b, now it is 2.5b. Even though the sampling frequency is higher, there is no way that one can recover the signal. Is this point clear? You see, ideally, if Nyquist sampling theorem is to be obeyed, the minimum sampling frequency needed is 6b. Isn't that right? 3b is the highest frequency content, the minimum sampling frequency is 6b. But we already showed in the class and also in the tutorial class with examples that sampling frequencies lower than twice the highest frequency content do suffice if the signal is a band pass signal. For a low pass signal it's okay. If you have zero frequency content also, then obviously the sampling frequency must be at least twice the highest frequency content. However, if it is band pass, then you can do with lower value. And in this case, you see 2b suffices. But 2b suffices, that doesn't mean you can choose 2.1b. It doesn't mean you can choose 2.5b. 2.5b leads to disaster, as you saw. However, if we increase to, let's say, 3b, let us see what happens. B, 2b, 3b, minus b, minus 2b, minus 3b. Now what will happen? Look, this minus 3b will now go to
minus 2b
plus b, because 3b is the sampling frequency. So you add 3b, so plus b, and therefore it goes like this. Alright, and this plus 2b now goes to minus b, and therefore it goes like this. Similarly, this will also be filled out. This will also be filled out. And therefore, from triangular spectra, right angle triangular spectra, you get a different kind of triangular spectrum. Is it possible to recover the original signal?
Yes, sir.
Ideally so, yes. What you have to do is to have a band pass filter from 2b to 3b, minus 3b to 2b. Now there is a guard band on the lower side, lower frequency. In other words, you can have a filter like this. Let me show in some different color. You can have a filter like this. That is a guard band, but there is no guard band here. And therefore, even if you fall like this, there would be aliasing. Okay. Now, which one would you prefer, 2b or 3b? In both cases, ideal band pass filter is needed, but obviously you will prefer 3b because there is at least a guard band on the lower frequency. Yeah.
So if I have it exactly as you have drawn, so it should at least have a constant amplitude between 2b and 3b.
Mm-hmm. Yes, at the 3b point, there is a sharp transition from 0 to capital A.
So
Right?
I'm saying the way you have drawn that.
This one.
Yeah. It's
Yeah.
not exactly right. So
No, it is not right. It will have aliasing.
no, sir. I mean, it should be constant between 2b and 3b. Otherwise, your
I've drawn what can be achieved in practice. For example, a simple resonance circuit or a mutually coupled resonance circuit, two resonance circuits coupled to each other can obtain such a waveform. There would be distortion in the pass band and also in the stop band. But so long as the distortion is within bounds, for example, if this is speech, well, you know, a small amount of distortion does not really hamper the quality. 3.3 kilohertz is adequate. Finally, question number 5. The mistakes you made in question number 5, a very modest term for this mistake is Himalayan. Because capital X of S doesn't exist. And all of you transform X of t, almost all of you. There are exceptions. You see, question 5 says, find the response of the system with the transfer function H of S 1 by S plus 5, real S greater than minus 5. In other words, H of t is even. What does that mean? Right-sided sequence. All right. This is the response. This is the frequency response of the system, and the input is x of t equal to e to the minus t ut plus e to the minus 2t u of minus t. Now, it is very tempting to find out capital X of S, multiply by H of S and invert, but that cannot be done. Because X of S, there is no ROC. There is no intersection between the ROCs of this, and therefore capital X of S doesn't exist. So what is the solution? Solution is superposition. It is given. It is not given. You have to assume. It was announced. Okay. Saving grace. That it's an LTI system, and therefore you take the input this, take the Laplace transform, that is 1 by S plus 1, multiply by H of S, and take the inverse.
So we can find HT.
You can find HT, yes, and then convolve. You want to do that? Well, this is what I call going to the hostel via 620. Why should you take that detour? It's not needed. Pardon me?
So that's the best proof.
That's the easier of the two.
But otherwise you will convert x into x.
But then you will have two geometric series.
Okay, whichever way you do, if you find that convenient, please go ahead. I did not find that convenient, so I solved it in a different manner. I don't think I have to calculate the whole thing. The correct answer is 1/3 e to the minus 2t u of minus t plus 1/4 e to the minus t plus 1/12 e to the minus 5t ut. This is the correct answer. We will close here. Just one announcement. The minor scripts would be shown day after tomorrow. Not tomorrow, day after tomorrow. Not minor scripts, I mean corrections, if any, discussions. Day after tomorrow, that is Thursday, 4:30 to 5. 4:30 to 5.